Hello, class. A little late, but hello, class. How y'all doing?
Hey there, Mr. Sylvester.
All right. That who this, Mr. James?
It's Mr. Jingles.
Oh, what's under the jingles?
Hey, that's cool.
All right, all right. How was my assignment?
It was like I had to get Twin to help me a little
How?
bit
How? You
because
could.
I forgot how to do the insert.
Oh, I gave you the VI command list. Remember?
Yeah, he had told me,
Right. Oh, okay.
and then I kept trying to compile it because I'm so used to Visual Studios. He was like,
But you see how you have different environments work different ways, and we try to teach y'all. Well, I know when I try to teach, I try to let you know that don't think in the box that when you leave out the classes, this is the only way to do it. This is how whatever, because you get on the job and like you say, they got it, Linux or they compile it in that form, and you're like, man, I ain't never done this. I don't know this, but it's just the way it is. But we teach in a Windows environment, but really C++ is in that Linux Unix environment. Yeah. But then it's different, like their platform. Some people use the Xcode, which is totally different, but the code is the same.
Mr. Sylvester, do you know we're gonna have a cloud computing class in October?
I'm not sure. I'm not. You might have to ask Miss Dore, because it might depend on the number of students that are registered for it. But when it's supposed to be?
It's supposed to be in October. At first, it was September,
Oh,
and
you
she
talking
pushed
about
it.
it's supposed to be like a second 7 weeks. I don't know.
No, she had pushed it. At first, it was September. It was like your class, and
Right,
then
but
she
September is the 12 week. If she pushed it back, it's gonna be the second 7 weeks. You understand what I'm saying? That's the only
yeah.
time. Yeah, that's the only time it could be. Yeah, yeah. So I don't know. Yeah, I'd have to ask her, and stuff. Now there is, but I didn't go to it. There's an advisement session going on at this time, but I told them I had a class. I don't know if you all knew about it and needed to go to it or whatever
That's that's for clubs.
for next semester. Oh, clubs. Oh, okay.
Yeah, they
Uh,
told us.
you sure?
Uh,
No, I thought the clubs was this morning. No, they did have
it's
one this evening. You're right. You're right. Because one hour teacher wasn't making it because of that. Yeah. But I'm saying they got that. They got the club, but I think they also had an advisory or something. But let me see how many people is in. Oh, we got 10 people. How was the assignment overall? Mr. Jingle said he had some little issues. Uh, and like I said, what your experience was like, what it was like. Anybody.
I looked up some commands, but after figuring out what the commands were, I had a pretty easy time with it. Actually, I kind of liked it. It wasn't too
Right.
difficult.
But I didn't give you the commands.
I don't know. I just whenever I'm lost or don't know what's going on, I just look up what I need to know.
Right, because if you notice in the notes, on the let me click here. Let me go to my screen here, share my screen. Because remember in the notes, you might need to, if you logged in to the website here before I got in, you may need to refresh your screen. But let me see if this is the one. There's this it. Let's see here. Yeah, when we was talking and we started talking about VI. Here, you see, and I clicked on this and I said, this is the list of commands. And then I also had it in Canvas. So these are, and now these are not all of them. These are some of them, but they got some other command
I
that you.
think I had to look up like a save command
Save it. Or ship. Oh, look here. Look down here. When you do
Oh,
it,
it says save and quit. I was having
right,
issues
right,
where
but
it wasn't
right.
saving to the same file, and I had to figure out what was up with that.
No, it had to be. If you did if you did a, you had to do the colon, shift colon, and
Mm-hmm.
WQ. And what happens is before you create the file, you giving it a name. You
Yeah.
understand?
Okay.
So whenever you do the right quit, it automatically saves it under that name. Now, if you just did a W, and I'm not sure, you could put a name at the end, then you giving it a new name. You know what I'm saying?
Mm-hmm.
If you do that, you get. But then all you needed to do was do the Shift ZZ, and you finish. It's gonna
Okay.
save it. Yeah, it's gonna save it. Yeah, yeah. But
Well.
you gotta be out of the insert mode though.
Okay.
Right,
Well,
right.
it got done at the end of the day, right?
Oh
So.
yeah, right. And like I said, I wanted y'all to get some of that experience because we take for granted a lot of the editors we have. We could just float around, click here, do this, that, and that VI man, it's challenging for some people, man. It is. But it's good. And you saw that you got to do what? C++ in a different environment.
Yeah.
Right. Right. So that was good also. Um, so so nobody have any big issues with that, right? No big issues
No, it's like the only issue I had, I just had to make another a command Linux command thing
to do
because
what?
for some reason when I opened it last time when we had the lesson, that was the first time I had opened it, and then I hadn't touched it since like maybe like
And what I
three or
tell
four
you, don't
days.
wait, right? Don't wait, because it could be one little step that you forget, and it's like, man, I don't know
Yeah,
what to do, where to go, what. You have
but
to create a
I couldn't get the
terminal.
no, not the
Oh,
terminal. What it was like the code wouldn't come off the screen, like it wasn't responding to any of the commands that I put in. So I just made another terminal and just like,
oh, right, right.
yeah,
Now, most times, they call it an interrupt, and like I say, normally it took up
yeah,
my thing. Normally, it's just like with Windows, you have interrupt because sometimes your system does what? It gets stuck in some kind of loop or whatever, or
yeah,
process that it can't get out. So if you do the Control C, and I think some parts say have Control D, but normally Control and C can break you out of it, and then you can continue on. Get
yeah.
the
Like I
downside.
tried like all the commands. Like I tried to save the file. I tried to exit, escape, all that.
Oh, you was in the content of the file though. You were
Yeah,
saying.
yeah, yeah. But the content wasn't disappearing, and it was kind of annoying because I wanted to like see like the other stuff. So
Now that could have been a memory issue.
yeah,
Yeah, that it was running slow or lagging or
yeah,
something. It could have been something with that. Yeah, it could have been.
yeah. But I just made another terminal,
Right, right. And I've
and
done that
that
too.
fixed it.
Right, 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 right. Yep. Yeah, and but you see how, and like I say, with Windows back in the day, pretty much that's how we dealt with Windows, where we had command lines, we had our file directory where we had listed, we had to know what's in it, whatever. But nowadays we have what? Windows, and we have what? Not even just Windows, our cell phone. We
Yeah,
have icons, right? Oh, I want to do this, just click here. Oh, I want to do this, just click here. We don't need to know what command makes it work, what's the parameters behind it, because we might check on such and such. We want to do this, but we want to add this, that, and we're not worrying about it. But behind the scenes, that's what be going on. Those are the type of commands that have to be executed in order for your system to do certain things. All right. All right. Anybody else? Anybody else? Okay. So what I'm gonna do, because I don't think I went over those folders. We're gonna look at those folders, and that'll be later. But after I do this, and then we're gonna come back and look at some more commands, and then I have another assignment. But what I got, I'm gonna show you the assignment that I have for you first. Uh, Let me just bring up this. I'll bring up this and go back to here. And oh, I didn't want to go here. I'll bring up the assignment. I'm already in Canvas somewhere. All right. And the assignment is not hard, but I have some commands in it. Not a lot of them, but some. We're gonna go over some in the class. And these commands are just like DOS commands, but some of them may be used or typed a little different. All right. This is the assignment. Not hard, but like I said, you got to make sure you take your time and do it, and even start it before whatever. Because if you wait, then like I say, it might not be as fresh. So what I did, I'm just, and this is the downloaded instructions, which is the same instructions. And by the time you finish, you should have, I think, 4 screenshots to submit to me. All right. But it says using the VI editor, create a file named _01_FILE. Okay, simple, create it. And so that means create it. So, and then it says insert the file name on the first line of the file and save it. So you create it, put the name of the file in it, and save it. Then it says create a second file and name it _02_file. I didn't highlight that one. All right, do the same thing, insert the file name, and then save it. Now, then it says copy 01 or the _01_file to _03_file, then 4, and then 5. But then it says copy _02 file to _06 file _file and _7 file. Everybody understand it? So all we doing, we creating 2 files. We copying one file into 3 other files, and we copying the second one into 2 other files. Everybody got that? Then it says using the single ls command. All right. Display the long format of all the files just created. So all I want you to do is list them in their long format and then take a screenshot. But what it say? It just says what? Of all the files just created. Now I should be more specific because I don't want any of the other files, class. I only want you to list the files 01_files through 07_files. Everybody understand that?
Yes, sir.
All right. I might need to go back and make it more clearer, but that's the only files I want you to list. But I did say using the ls command, display a long format, the long format of all the files just created. And I should have said only, but.
So just to clarify, you want a screenshot of, it's going to be 01 to 07. It's going to be all of those.
Right. And now you might have something above that command. I don't mind that. You understand what I'm saying? Right. But I'll be able to see that ls command and what you typed and then the results after that. You got me?
Yes, sir.
Right. All right. So now, then it says, take the screenshot and which you're going to submit in Canvas. Then it says, now create a folder named My Files. But look at the capital M and lowercase y, capital F. Because remember, in Linux, it does make a difference with uppercase and lowercase. When we with Windows or DOS, it doesn't matter. The file name, My File this way, or all uppercase, it's the same exact folder or file when you're dealing with Windows. All right? So once you create the folder, using a single command line, well, it means one command, copy all of the, all of the 7 previously created files into that folder, your My File folder. So now you're gonna copy all those files using one command, not copy this, copy that, copy that. And then what you're gonna do, let's see what it says, because you're gonna screenshot something else too, because I'm gonna see that command. Then it says, now Execute these 3 steps in succession. So once those files are copied with that one statement, then it say display a long format of your user folder. So what? If you just created that folder and you just copied all that information in that folder, when you do a listing of that folder, it only should have what? Those 7 files in that folder, right? All right. Then it says display the long list of the content. I don't know why I have so much space here. And then it says take a snapshot. So that snapshot should show me that command, that single command you use to copy it, and then that single command you use to, well, not say that single command, but these commands here you use to display the information and then the screenshot. All right. And like I said, it's not hard, but you'll get to maneuver through it saying like, man, it's just like DOS, if you knew DOS or whatnot. Then it says using the VI editor, all right, edit the file 07_file, all right? Now, and on lines 2 through 10 in class, I don't know why. When I ask you to give me a 1-page document, I want a 1-page document. I don't want a paragraph. I don't want 2/3. I want a 1-page document. You can go a little bit beyond. I don't have an issue with that. But when I give an assignment and you choose to just give me two lines or 3 lines, when I'm talking about a paper, and you just give me 2 lines of information saying what a buffer is, I'm like, I'm not getting it. Because in essence, I could tell you to write a 10-page document, and then you're giving me all kind of BS through pages 3 through 10. You understand? But I just asked you to give me a page of information, do your research, because you learning it. Hopefully you can learn something and go through it, research it, pull out the meat of it, and you're learning it and you're giving it back to me. But some, like I say, I can't make you, but you know, some people choose to not want to follow the instructions. Well, I gave, well, okay. So this says, and I've said that because of this, lines 2 through 10, give your opinion on the VI editor, all right? Then save the file. But look at this, it says, each line should have at least, well, have a minimum of 10 words. So now you're gonna have lines 2 through 10, which is what? 9 lines. So 9 times 10. So that's at least 90 words you should have in that document. Everybody understand that? Right?
Yeah.
Yes, sir.
Okay. And like I said, I just wanted to be clear. I don't want somebody to go, oh, I like the editor, boom, boom, I'm finished. Or I, next line, like, next line, D, next line, editor. I'm like, why? I'm not sure. So like I say, at least 10 lines, 10 words on each line. Now, from the $ prompt, display the contents of, now it didn't say edit. You gotta be aware of that. It didn't say edit it. It say display. We're gonna go over that too. All right, display the contents of the file 0_07_FILE. Then take a screenshot of your desktop to be submitted for a grade. Now, then it says, display the content again. Well, I got this twice. Or did I read it twice? All right, I did it twice. Okay, now oh no, here we go. I skipped 19. And see, if you skip it, it's gonna have your content messed up. Now it says, now concatenate the contents of _01_file to _7_file, 07_file. So I want to take the contents of 01 and I want to put it into _07 underscore file. Everybody understand that?
Are you
Everybody-
asking us to replace or just add to? Add to.
Look what this say.
I don't know what that
Concatenate.
words mean. I'm not an English major.
Oh, okay. I'm sorry. Yeah, that
Word.
means to add on. Yep, to add on. To add it to. Because
Okay, cool.
in what it wasn't it 1933 when we took a string and we did like say string name 1 and string name 2 could have been your first name and last name, first name with a space in it at the end, and we did say full name is equal to name 1 plus name 2. What we did, we concatenated the two and stored it into a full name.
Okay.
So that's concatenation. You're adding two.
Gotcha.
All right. So
And these
go ahead.
are basically just text files. That's just pretty much.
yeah,
it.
that's the file you created.
Okay. Well,
Yeah.
I'm asking like, is file the name of like, or is it a
Yeah, that's a
dot
part of
text?
the name. That's a part of the name.
No, I meant like, is it a dot text file?
No, it's just a text file, right?
Okay.
See, Windows give it the extension .txt. See,
Right.
in Linux, you in control. If you don't put an
Oh.
extension, it's not gonna give an extension.
Cool.
See,
Okay.
when they started doing Windows, it's almost like say, well, I'm a do so you don't have to think. When we create a document, when we create like a Word document, it put what? That extension on it. Linux is more or less of a, how would I say, a upper level user system. So whatever you want to be, you have to make it that.
Okay.
You know,
Tell it to do everything.
Yeah, everything. You have to tell it. It's not going to just say, oh, well, he want to do, no. When you do VI, if you do VI underscore or 07 underscore file dot TXT, then it'll make it that file name.
Okay.
You got it? Right. It won't.
It is unnecessary to add the dot text for Linux.
Oh, yes. Yeah, unnecessary. Even in the Windows environment. The only reason they do that is so that the Windows can kind of associate that file with that application. Other than that, it's really not needed.
Mm-hmm.
You know what I'm saying? It's like JPEG files associated with what? Images. Now, and I mentioned this to students before with the Windows environment. Sometimes the extent, and it depends on the application. Like one application might say, when you load it on your system, oh, I see this file out here. It got an extension that I recognize as being what I need. Like say Windows. If you see a file with .doc, you try to open it, it'll try to open it because it's looking at is .doc. Some files, it say like, I'll just say like a video editing application that do MP4s. It'll see an MP4 file, but if it's not, well, so you could take an image and make it say photo.mp4, but really it's a JPEG, right?
Mm-hmm.
And this application might say, well, I see that file there, but I looked at the format, but the format doesn't jive, so it ain't associated. So some applications look at the content, some look at the name, you know.
Speaking of which, when I had to change my screenshots from PNG to JPEG.
Oh, so I need to change. I think another person had an issue. She said she couldn't change it. So
Mm-hmm.
what I'll do, I'll add JPEG because normally, well, I guess Windows now by default, it does JPEG.
Yeah, I think it does. All I did to change it was I just went into MS Paint and just
Right.
I just changed the file name. And
But
then,
I didn't even think of that, dude.
See that what I'm saying? Just look at
I'm so mad.
Right. But now let me ask you this. What do you use snippet?
Oh, I just use print screen.
Print screen. Yeah, control print screen, right.
Mm-hmm.
Because now I'm gonna show you right quick if I can get to it. I'm gonna hit the window button. Down here, if you type snip, it's so. It's pretty good. I use it at times. Like say the snippet tools. You go here and you say new, and the mode. you could capture a window, a particular window that's open. You could actually create, do a rectangle around what you want to do. You could do the free form, like you do a circle or whatever, or whatever shape, but I could do full screen. If I do full screen, bam, it captures the whole screen. And then I can do file and then save as, and then it's JPEG, or whatever. See, this is the PNG here.
Yeah.
So that's why I did it that way. But I'm gonna change the PNG. But
well, you can
but
just
that
make
way
it
you don't
where
have to
it's
do
both.
extra process, huh?
I was saying you could just make it to where it's both. That way it's not like ever an issue.
Whereas what?
Where it accepts both JPEG.
Oh yeah, that's what I'm saying. Yeah, so it won't be a
yeah.
problem, right? Okay, but that's that snippet tool, and that comes with Windows, so you can use that if you choose to, or you could do it like you say, control press screen to capture it and whatnot. And so, like I say, you're gonna concatenate the two, and then you're gonna display the content. Now, really, if you remember, 01 file only had what in it? This file only has what in it? The file name, right? So remember up here where we told it to create it and insert the file name in the first line. So when you add this into this one, all it's going to do at the bottom of it is add what? The file name, right? And that'll be done, okay? And then you're going to display it. We're going to show your words about it's going to show O2 file, and then it's going to show your expressions on VI, and then it's going to show O1 underscore file, right? And you take a snapshot of that, and then you just upload those 4 files to Canvas. All right? Any questions?
No, sir.
All right. So now what we'll do, no, I don't want to say that. Now what we'll do, we'll go back into, where is it here? Yeah. We'll go back into here, and let's look at, and I moved some stuff around. That's why I told y'all you might need to refresh your screen. If we go back to the first one, the first lesson, what I did, I just moved some stuff to this side because it was kind of out of place. So not say out of place, but not organized the way I had it. So here we have, we talked about this already, but here, processes, all right? And I'm gonna talk about processes, and then we're gonna talk about starting a terminal, which we already started a terminal, all right? Which a terminal is dealing with all this. But then we're gonna get to the structure of how our folders are set up in Linux or Unix, all right? So processes. And a process can be simply defined as an instance of a running program. And what happens is we as users of the computer and really in a multitasking environment, when we run a process, or like say we working with a company and we running a process, or say executing a small C++ file. We sit at that computer, and when we hit enter to execute that file, we in our mind, we thinking our program is executed from start to finish, but it's not. We are given so much time over the different users and processes that's running on the system. But it's being done so fast that you're getting that time, it look like you steady progressing. And that's what allows your computer to look like everybody is progressing at the same time. Meaning if I hit enter to execute or run a process or program that I have, somebody else click on the website and they're on that system, and somebody else click for another service, the system really is giving everybody a shared amount of time, and everybody is moving forward at the same time. And depending on how the system is set up, whether it's first in, first out, a shortest job first, or they're gonna process them all at the same time, gonna depend on how fast your process or executes. All right. So basically, that's what a process is. Any type of execution that's going on within the system, and you're going to get, which is the running program, and you're going to get so much clock time until your project is finished. All right. It should be understood that a program is a part of a file system that resides on a non-volatile media, which is your disk, all right? And a process is an entity that is being executed while with at least some portion or segment in RAM. So it has to be loaded in RAM in order to use. Every system has to have some sort or some type of RAM in order for it to be operable. If you go to your computer and you remove your RAM chips, can't boot up. So you have to have that RAM, all right? One may say that the file system has places and that processes have life, in which you could say all your files are what? Stored on a disk. All your processes have a life cycle, and when you kill it or whatever, it's gone. All right, but the file is still there where you can execute it multiple times, all right, over and over and over. So since we know that Unix is a multi-user, multitasking operating system, we know that multiple processes can be running on Unix systems at the same time. Not only can multiple processes be run at the same time, but on a typical multi-user system, hundreds of processes are running at any given time. Because what? Just because I'm on the system, it could be your computer. When you run it, when you're doing things on your computer, it's more than what your computer is doing more than what you're doing. If you can understand that, the system is monitoring things. The system is processing some things in the background. How many people used Vista?
Yes, sir.
The Vista operating system.
Yeah.
Vista was somewhat, how would I say, it came out new, but Vista had issues. Why? They had too much running in the background for people. They tried to do everything for you, which sometimes you was working on your computer and it's like, well, what's going on? Because what? A process would just start, but they thought, or they figured that they was going to make that operating system manage your memory, manage your RAM, manage everything for you without you having to schedule it or do it yourself. But it caused a whole lot of issues, and I know I didn't like it, and a lot of other people didn't like it because it took control of your system at any time. You didn't have no control over it, and it kind of fizzled on out because it had too many things running in the background. But we know we have to have certain things in the background. Our firewall is running. We even have our antiviruses. All that stuff is running. And so that's processes that's running in the background. But we think I'm on the internet, that's the only thing I'm doing. No, it's not. It's a whole lot of things that be going on the system other than what we are doing. All right? And like I said, it would be a process. Each time a program is run, a process is created, all right? All right, typically with the same name as the program itself. It could depend because what if you have the same name, all right? Some, all right, if the GIMP application, and now this application, if I'm not mistaken, GIMP, they created a graphical interface with Unix, and so. If some GIMP applications program is running, the program, a process with the name of GIMP is created. So it's just telling you if those applications are running, it'll create that process with that particular name. Most systems have only one GIMP program, all right? But if 5 users run a GIMP program, there will be 5 processes created named GIMP, okay, one for each of the 5 users. If the processes have the same name, why doesn't the system get the processes confused? Because now processes have the concept of a lifetime associated with them. Processes come to life and are said to be what? Born. And like I say, it goes into that whole thing of parent, child, and all that. But that's just the terminology they use. When it's born, that's when it's first started. The process is started. As the program is loaded and being executed. Programs remain alive while the program, and that's self-explanatory, continues to execute. All right. However, processes, however, can have different states of life. Because sometimes you can be in a dormant state. You could be sitting there waiting. You could be in the active state where what? I'm actually doing something. And then I could be in the wait state where I'm in the queue, but it's like I done got my time, I'm still waiting. Got my time, I'm still waiting. But dormant mean I'm not even on the list yet in the queue, but then they go call. Once it get freed up enough, it'll bring me in, now I'm in the queue. So it's different. A lot of things are going on in the operating system. It's just this is almost like talking about the operating system class. All right, so processes cease to exist and are said to die as the running programs terminate. All right, and normally you want your programs to terminate what? In a normal fashion. But sometimes like we were just saying earlier with Mr. Labrie was talking about, well, Mr. Vestock, it didn't want to let me do the right quit, whatever. Then we started talking about what? Interrupts, right? So sometimes you can interrupt a process where you can use what? Control C. And then sometimes people just do what? Turn the computer off altogether, right? Or you can what? Exit out of an application. If you have an issue with a tab with a Windows, when you are loading something, when you're in online in a website, what you do? Man, let me close that website and come back into it. So you just kill that process, right? So those are some of the things that do happen. All right. So, and all processes except the very first one have a parent. So like I say, you have a parent process, and then from that, you can have you can have a child created from that, and then you have the child can be a parent, then you can, so it goes down into levels, and then you have different levels. But then it can be killed at certain levels, then that's when you start having the zombies and everything spawning off and all this other stuff, which is talked about further down in here, or what we talked about it already in the first part. All right, so what happens is we have the parent which creates them. Similarly, when a process is created, it is created as a child process. So it's created dependent on what the parent is, all right? So with the process responsible for its creation being the parent, okay? Why can't the world work like that? But that's computer science. All right, when a process creates a child process, it is said to have spawned, all right? So it just spawned out a child. So now, every process on the Unix system must have a parent, okay? Again, because how you gonna just have a child with nothing? They just say, okay, just showed up. And apparently, well, no, even if a virus is injected into the system, it has to be a process that was created, and it's something spawned from that process. All right. So each that would say each parent, each child, or each process in the Unix system must have a parent. Okay. Now, so it says again, except for the very first one. All right. Since often processes are not normal. Okay, normally allowed. So also all processes on the Unix system can be linked to one initial process. All right. So even if I have my process running and it spawns many children, it should be really related to some process. All right. It's not out there, and not knowing where it was created from or whatnot. Then you got an insecure system if that's the case. All right. So as you will see, processes have a similar hierarchy structure to that of the file system, because I don't have an example of the file system, but normally with a file system, you start with the root, all right? The root normally is your backslash, or in Linux, they use the slash, but there's in Windows, the backslash. That's your root. everything is created for the file system. Everything from that is created. Any other files can be stored in the root. Any other folders can be stored in the root. And then from that, you can have folders that within folders from those folders and files. And then from any other folder, you can have other folders and files. All right. So that's what it's trying to say when it's pretty much the same. Right. Each process has many attributes associated with it. All right. And a process attributes are stored in a structured memory, which is called the process control block. So, I'm sorry about that, class. I'm my phone over there. Let me close this up. All right. So, close it up. It's gonna stop. That's my whole phone. All right. So we see that what? Even though you have different processes, now the system has to maintain what? Or you have information associated with those processes that the system has to maintain, those PCBs, and those PCBs has information that controls what, how, whatever, access, when, whatever. So you have all this stuff going on within the operating system. All that's controlled by the operating system. So you have all these multiple processes running. These multiple processes got data associated with them. Kind of like when we talk about pictures or files. Files have something called metadata. And metadata is pretty much data that's associated with the file that you pretty much normally don't see. All right. And like, to give you an example, if I email you a PDF file, now you'll look at that PDF file and say, oh, this is the content of that PDF file. But that's not the only content of the PDF file. When you open that PDF file, to open it, it's going to have a file name, it's going to have a date, and maybe a date it was created. It may have the owner who created it, if you look into the like file properties and stuff. So those files have all those things associated with it. That's how a lot of times, and I would just say, dumb criminals get caught. You know, here it is, you committing a crime and you taking photos, and what? The photo normally have the date, the time, the location, you know, and I'm talking about the geographical location, where it pinpoints exactly where you are. But then you got evidence to what you did and don't know that you really incriminate yourself because you're holding on to evidence. But I'm just saying, many times you have data that people don't, that you don't see, that's a part of, what's going on. And a lot of that goes on with computers all the time. I'll give you an example about, and then we have log files. Now, log files are not necessarily metadata or whatnot, but many people and operating systems, many operating systems have log files also. So they can do audit trails on what was done at what time, when backups, if backup was done, when it was done, if the system was rebooted and when. All those different things are stored so that you can go back and check to monitor and manage your system to see if any kind of fishy things have been happening with your system. All right. Now, so let's say each individual process will have a PCB associated with it. So every time a child spawns off, it's going to have its own PCB associated with it. And the system has to maintain and know, and those, they have to link so that what? A child won't get broken off and then now they're out there in limbo and can't, your process is broken. All right. So attributes are relevant processes. Okay, each process have a unique numeric identifier associated with it referred to as its process identification number, all right, or PID, all right. Each process also has a reference to the PID of its what? Parent. Because remember, when a child spawns off, in order for you to close out of a process in a normal fashion, everything has to go back to what? To nothing. All right. Otherwise, what? If you break off a process at the bottom, then you cut it off, and then you might have stuff that's just dormant. So everything has an association. All right. So it's like it has a reference to the PID of the parent, i.e., the parent process ID or the PPID. All right. Each process, so a child in a sense can become a parent, and then it child would have a process ID, but then it would have its PPID. So each process will have properties associated with it, i.e., the properties of order of execution. All right. So because when your processes is in the system, if they are not, just like when you code, are not in the proper what, or is not executed in the proper manner, then you could have issues where, oh, well, why is this being done? I don't know what's going on. So now your system either locks, your system goes into some slow whatever, and that's normally how they interject viruses. Because viruses is just really interjecting the system to make it function abnormally. And like I say, depending on how well of either a code cracker you are or whatever, you might do something to attack memory, or you might do something which I mean RAM. So like I say, well, mess up the order in which the stacks of the processes. They might have something that hackers might mess with the file content itself, where it might make it balloon or extract something out, and then all of a sudden now it can't really execute properly, and it's doing whatever, and the process can't run properly. So it might even just delete something altogether. So it just depends on what that hacker is doing or want to accomplish. All right. Each process will have I mentioned that one. Processes have ownership attributes associated with them, both from user level and group level. Now, remember, and we didn't go over it. Well, I'll wait on that because I don't think we went over that, the change mod. But anyway, I showed you that where it had the RWX, 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 and then it had D for directory. You have the user permissions, group permissions, and the other. But I'll go over that to show you how that can be changed and whatnot. All right. So each one have they have levels of attributes. Now, processes will have a state attribute, all right, associated with them, typically assigned and updated by the kernel. So like I said, depending on what state they're in, dormant state, ready state, awake state, whatever. So always execute. All right. And what I did, I think I put the same slide in twice. I think I did. Yep. All right. So, and I think we went over that. What is a Unix terminal? Now you already know what a Unix terminal is now because you done did the first assignment. That Unix terminal, allows you to, as a user, to interact with the computer. All right. So, every general purpose computer consists of hardware, right? And we know that hardware, system programming, which is the software that is loaded so it can open up and execute, all right? And then application programs, which is the program that supports the user and the needs that they have, all right? And then the user would be the actual person to use it. But not all computers are designed to have, user interaction. And I can't say, how would I say it? Well, I could say some have limited user interaction, put it like that. Because if, how would I say it? Normally when you put a satellite out, satellite is just a big computer. All they doing what? The satellite just feeding information, picking up information and sending it, whatever. But at the same time, they may have to what? Realign it, do whatever. So you do have a user that's somewhat interacting with that satellite, but may not be as often as just sitting down at a computer and doing something all the time. All right. Now, the data structure. I kind of talked about the structure of a file system, and if you were coming from Windows, which most of us are, the Linux system structure can seem somewhat alienated. All right, like I said, alienated. But the C drive, all right, which and the letter and the drive letters are gone and just replaced with the slash. All right. In Unix and Linux, when you see the slash, that's the root directory or the root folder. I'll give you an example. I don't think I even have it open yet. I have it open. So let's do this. Let's do this. If it comes up, it's lagging. See, they're not, but every time I get to it, it's like it lag a while. It's gonna come up. It should, unless I just create a. Tell you what I do. I'll just come back in and see what happens. I want me to come back in. Come on, Chuck. See, it's lagging. Why? What's going on? Let me log on to this. Well, that just killed the process, right? So let me go back. Let me go ahead and do that. I'll go back to here. Go there. No, it's not coming up. Oh, there you go. And it's still not going. Why is not going? Why no one? Why my system is not doing it? Unless let's have another one open somewhere, but I doubt it. I was in it. I was just in it. Hold up, Clyde. Let's see something. I don't have one in there. Oh, I got one in there. Let's see something. Okay, let's see. This is another one. That might be the one I got closed over. Let me close this one. Let's see this too. Go here. Why? Let's see something. All right, finally. All right, let's see if it's working. All right, so now, gotta remember what I was doing. What was I on? Okay. I said, oh, did I set it off? I forgot what I was going to. Oh, if I do a PWD, all right. Notice you don't see no drive letter like A. Well, not A, C, D, E, or whatever. All you see is what? /home/user. So this is where all, excuse me, this is where all of my my files are located. This is my home directory. Because if I do the ls -l, I'll tell you, that's my folder. Now, so I can do a cd dot dot. Now I'm at the home folder, and it just have one one folder. All right, I'll do a cd dot dot. Now I'm gonna clear it. Now I'm at the root. Okay, so now I'm at the very top. I'm at the root. All right, the very top level of my file structure. Now, if I do ls -l, I'm gonna do the long version. Now you're gonna see all of these folders. Now, these folders are system folders, all right? And we're gonna look at a few of them in the notes to see what some of them are does, all right? But just looking at it, this bin folder, all of them, you're gonna have a bin boot. Well, 9 times out of 10 is where the information, but watch what happens when I go to boot. I can get to boot, but I might not be able to list it. See, I can't list anything. The etc, if I do a cd dot dot, cd etc, it might let me list it. Oh, it let me list it. So I can list it, but really I don't have any privileges to do anything. But a lot of this information, that's system information. Cd dot dot, ls -l. All right, I think it's ECT, CD slash D slash ECT. All right, ETC. All right, I'm looking for, yeah, I see shadow. See here, this is where is it? This is where the passwords are located, class. These are the file. This is the file where all the user passwords are stored. But I'm just showing you that. But I'm saying if you were on a Linux system, you was on super user, you would go to /etc, and then in that folder you would see that password folder. I think they even have a host folder. Where's that host folder? The host folder allows you to do an allow on who you would like to come in. See, look. Allow and deny. So you can allow certain and deny. So it's just like Windows, but it's just a little different where you have to physically edit those files, put in your parameters, and save it. If I try to open up that password file, if I do well, I'm showing you a command we're gonna be using. Cat PS, is it PASFWD? Oh, I say showed it. So this showing me all of the users in that password folder. Now, I really forgot what a lot of this mean, because a lot of it too is really encrypted. All right. Well, the other file with the dash on it is the actual real encrypted file, but this one is somewhat encrypted too, because you can't really see the files that's on there. Who put X's on the screen? Okay, so let's go back. So the root directory. Everybody know what a root directory. I'm gonna go back to so who just X'd out that the screen? You can remove it if you did it. Hello? I see, I don't know how to remove it.
It has to be the user, I believe. It's the same problem from the other class.
Right. So, but I'm saying somebody in the class, though, right?
Yes, sir.
That's what I'm saying, and they listening to me, right?
Yeah, they may just not know what they did.
but they listening to me.
They are listening to you.
And they seeing what we see.
We see it.
Right?
Yes,
and I'm
sir.
asking them to remove it. Oh, well, whatever. See, they put something else in it. I don't know. All right. So let's continue. So let's look at I'll tell you. So this it tells us this is the top. This is the top of the file structure. All right. So now it says the file system hierarchy standard defines the structure of the file system of Linux and other Unix-like operating systems. All right. Now the root folder. Everything in the Unix system is located under this. That's the top. Everything goes from that down. But you don't have D colon, you don't have C colon. It's not like that. Not like Windows. That's only in Windows, and that's all it's saying. You'll just see that root. If you see this by itself, when you see in a folder or whatever, or when I did the PWD, that means you add the root folder. Now, there's a /bin folder. /bin, it tells us it has the essential user binaries, right? Which contains essential user binaries or programs that must be present when the system is mounted in single user mode. So all these different folders have specific purposes. And I think in this bin folder, if I'm not mistaken, even when you install something, I think it puts it in there, in this folder. And then, you have access to it. All right. Now, /boot, all right? It's a static boot file. This boot folder contains the files needed to boot the system. So however you it's configured for your system to boot, that's where that information is stored in files in that folder. CD mount, the /CD-ROM folder. This folder has all information, basically where you are to mount CD drives, etc. So the directory isn't part of the file structure in a sense, but or the file standards, but it is still you'll still find it on Ubuntu and other operating systems. All right, it's a temporary location for CD-ROMs inserted in the system. So some systems, well, Ubuntu said they say have it, but many other systems they don't have it. /div, all right, all your device drivers and whatnot. Linux exposed devices as files, okay, and /div. So like, how would I say it? When you have like a C, what I want to say, a floppy disk, been so long, a floppy disk drive, it's not recognized as a drive. It's /dev01 or something like that. It does not have that single letter name like Windows have, all right? So you would have those type names. Or like here, you got something here. This represents the SATA drive that may be on the system, /dev/SDA. All right. So you would have a name like I say, it's like dev01 / like say SDA or whatever. So it doesn't have an actual letter, it have a somewhat small name. Okay. So if you wanted to petition it, you would have to start your petition editor and tell it to edit the /whatever /dev SDA to petition this particular drive if you had installed it in your Linux system, after installing everything else. All right. /etc. All of them have this /etc with which is a lot of your configuration files. The /etc folder contains configuration files which are generally which can generally be edited by hand, and like I say, VI. But like I say, USD, if you're the super user, you can go in and configure your system to do certain things, how you want it booted, like with your /boot, but how you timed out on such and such, doing whatever, all those different things you can configure it. You figure your system with files in that folder. All right. /home folder, the /home directory, I said folder, but they said directory, same thing, contains the home folder for each user. So remember, I was a user, right? But I have home. I was on the /home, then what? /user. All right. See, look, /home/Bob. So this would be a folder for the directory path to Bob's files and folders that he have created. All right. This home folder contains the user data files, and user-specific configuration files. Each user, now, because really, now it says configuration files. Let me go back and show you why. I'll do a pwd. So I'm back here. If I do a ls-l, it only shows what? My files, right? Now these files they're not hidden, all right? But if I do a ls-la, like the A gonna give me all. Notice what happens. Now I'm in the same folder, but all of a sudden, .bash history, .bash HRC, .git config. So all of a sudden now I'm getting all these other folders, and most of all that is how my system, is for the configuration of my user account. Okay, so that's what a lot of those things for my user account and how it's come up, what privileges I might have, et cetera, et cetera. All right. So like I say, same command. All I did was added the A. I'll take the A off again and show you. Look, it only shows what? My files, the files that I created. All right. But the other one, it shows all hidden files and my files. Okay. So now /lib shares libraries. Okay. Library directory contains libraries needed for essential binaries in the /bin, the /sbin, and the /sbin folders. All right. Libraries needed by the binaries in the user/bin folder are located in the /user/bin library. All right. Well, the /user library, LIB. Now, then we have these are other folders and their purpose. Lost and found, well, you have recovery files. Media, removable media. MNT, temporary mount points. All right. So you might mount external something or USB or whatever. So you can have those temporary mounts. /OPT, optional packages. /proc, okay, that's the kernel and process files, okay, contains special files that represent system and process information. /run is our application state files, all right? It stores the transient files, okay, they require, okay, like sockets and the PID. So what? Or when something is running, it's PID that's kind of stored in there, gets till it completes and it's up. The /sbin we just kind of talked about contain essential binaries that are generally intended to be run by the root user for system administration. And like I said, a lot of Linux, like I say, for the most part, is on the administrative side. A user get on there normally gonna just, like I say, compilers and do whatever. And then now they create interfaces like graphical interfaces. They've been doing it, but they're trying to, make them a little bit better. But for the most part, if you're Linux and Unix user, man, you're a command line a typer. That's all you love, just a command line. All right. /SE Linux. Okay, contains special files, all right, used by SE Linux for Fedora and Red Hat. Now, I've used Red Hat Linux before. Like I say, once you use one, they all basically are the same. like you say, your /bin/etc/whatever, and then your host file, password, folders, and file names. Your naming scheme and whatever are very, 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 very similar. Like you say, minus some of the maybe added folders or whatever that they may have or whatever, or they may add in a particular application. /SRV, all right, service data, all right, contains data for the service provided by the system. All right, /TMP contains files that are generally deleted whenever the system is restarted. So that's temp files. Now we know, like sometimes Windows have temp files also, but I think Windows don't delete their temp files, if I'm not mistaken. Most times, and it just depends too on what type of temporary file it is. But most times, when Windows, you got to go back and wipe out a lot of those files when you got to do a cleanup. All right. Then the /USR, we talked about that, the user. Okay. This where the system administrator mounts temporary file systems while using them. And then the last one, /var. /var is one that's commonly used too. Okay, variable data files. Must be read only, okay, in normal operation. Okay, log files and everything else that would normally be written to the /USR during normal operations are written in that folder. All right, so that's some of the other folders and whatnot. Now, let's go to the second part. Now, this part here is going to allow you to do your assignment. So when we go down here, we did the VI, but then look here, right here. We did this command, this WC command, word count. This word count command. So in actuality, class, none of you should do what? Should turn in that assignment where I told you to put in so many words on the line, not having enough words in it, correct? Right? Because if you got this command, and I'm gonna go here, if you got that command, you should be able to do, like say, if I take a file, I'll just say, I'm gonna do a cat test. That's gonna just show me the content. This is what this file, the file test has in it. This information. The cat just display the contents of a file. So if I do WC test, all of a sudden, now it's showing me that I have 90 words in it. Because what? The first one is the total number of lines. Oh no, it's the second one. The second one is the total number of words in the file. And the third one is the number of bytes. So really, is the second one where I have 22 words. So I have 22 words in the file called test. So before you create or whatever, or you don't have to, but you can run this test, this WC and the name of the file, and the second column would tell you how many words you have in that file. Now, you know you're going to have the information on the first line and the information on the last line, but you still should have, on average, have, say, 92 plus words in the document. All right? Now, that's the WC. Now, and you can do it on more than one file if you choose to. All right? If you wanted to copy a file, CP, the name of the file, and then into the destination file. All right? Just like in Word, if you had one, you could do that too. And then you got move MV. It moved the old file into a new file. All right? In a sense, this command somewhat renamed the existing file, okay, and existing file name to a new name. So it's really like you're not actually leaving it there and just move. You're actually taking it and giving it a new name. Give an example. Let's do the CP. So I'm gonna do CP test, right? And I know I'm in that folder, and I know test is in that folder, because if you try to type a name that's not there, example, if I say test 111, I want to copy test 1 to test 3. So it's gonna say cannot no such file or directory. See here, test 1111. So CP test to test 2. All right. Now I can say cat test 2. So I just copied what? The contents of test 1 in the test 2. But if I wanted to rename test 2, I wouldn't do a copy. I'll do an MV. I'll do an MV, and that's renaming it test 2 to test 3. All right. So what I've done now, if I try to do a cat test 2, it's gonna say no such name or directory. See what I'm saying? Because I took it and I moved it to test 3. All right. So that's the copy command. All right. Now here is your rename, remove, not rename, remove. It deletes a file. So when you do RM in that file name, it's gonna wipe it away. It's gonna completely remove it. You won't have it anymore. Now you can remove more than one. Now, class, some of them you can do the wildcard. You know what I'm saying? So let's go back to here. So say we do RM test 3. I've just removed it. If I do LS, well, I don't have to do LS. I'll do the cat again. Cat that, no such file, right? But if I take test 1 and I'll say CP test 1, test, I'll call it 22, 33, and 44. All right, I could have put an extension on it. All right. So now what I could do a RM test, all right? Now, so now I don't have a wild card, but I got the word test, and any file name with test with 2 more characters, it should delete them all. And now when I do, I'll do an LS minus L test. I just have that 1. But let's do LS minus LT asterisk. Oh, wait a minute, why? L, that's right, T asterisk. All right, see I have test and test 1, where test 1 had 1 extra character behind it. So it ignored the delete statement, because if it had 1, it would have been deleted. But I use question mark right here, question mark. So it say for a test, and any test word file name with test and 2 characters after test, delete it. I don't care what the characters are. All right. But then I got the error with the dot asterisk, because what? I think at the beginning of the class, I forgot who that was, asked me about file extensions. I forgot who it was. These files were created without an extension. So I'm telling it to delete files with an extension, and it's saying, okay, well, I don't have no files named test that has extensions. But if I would have had test.cpp, it would have deleted it here. It would have deleted the file. All right? So those, like I say, and then over time, you'll get to understand it. Now, the cat command, it stands for concatenate, but you only concatenate when you use this stream here, all right? So you got to understand that. You got to understand when it's being used. If I just say cat in the file name, I'm just getting the content, okay? I could say cat 1 file name and another file name, and I'm just showing 2 files, all right? So, and then if I just say cat stream here file name using this single one, this it displays the content of 1 or more file on the screen without pausing. Well, that's what this one does. This one actually directs it to a file. But like I say, let's see, cat, the symbol to a file, which is here. Okay, if the file already exists, right, the content will be overwritten. Look at this. See here, if I do cat and the name of that, the information to here, it's going to take the information from here and overwrite that one. So because I use that, let's see, man, I'm gonna have to show you. I'm gonna show you what happened. So I have test one. Let me see, cat test. I have that. Now that's what? How many lines? 1, 2, 3, 4, 5, 6. 6 lines. So if I say cat test one, test two, I don't have a test two. I'll do CP test one, test two. All right. So if I say cat test one, test two, that's just gonna show me both of them. Let me clear that. All right. That'll show me both of them. All right. So all I did, they both was the same. So this is the first one. That's the second one. If I do cat test one, I don't know why I put that stream in the front of them. Cat test one, test two, and then I do the cat test two. Look what happened. It took what was in test one and did what? Overrode it. I don't know why. But if I do it this way, like I said here, like this will concatenate the two. Might get an error. No. Yes, I did. That's not right. No. Control C. All right, breaks down. So why? No, I'll put that down. I'll put that. I messed up. I'm gonna have to fix this in my program. I mean, I'm gonna put my file because this is not right. That stream shouldn't be there. But this shouldn't. And this is not right. They shouldn't use that. All right. Now, yes, that is it. Here, that's wrong. So here, this is how I would concatenate two files, the double stream, all right? So now what happens, let me go back to test one and test two. Here. So remember the first time when I did the cat, I did string cat one and cat two. Well, not that one. Yeah, that was right. Cat one, there's nothing in it, I don't think. Yeah, it should be. Cat test. Nothing in it. So I'll do a CP test two. Come on, computer. Test two to test. Now, so now I'm gonna do the cat again. So I'm gonna cat them both. Wait a minute. So I must have deleted the information I had in them. So what I'll do my names. Okay, let's see something. All right, so I have these names. So what I'm gonna do, I'm gonna copy it into another one. Okay, I'm gonna say CP names .txt, and I'll say name .txt. All right. Now, if I want to copy the contents of one into the other, well, first of all, what I'm gonna do, I'm gonna open this one, VI. I'm gonna open this one and I'm gonna delete. I'm gonna go here and I'm gonna go down here and DD, I'm gonna say 4DD. All right, so it deleted that, DD. All right, so I'm gonna go to the end. I should have did capital A, and I'm gonna put 3 blank lines. All right, so Shift ZZ, I gotta hit escape to get out. I need to insert again. 2, 3. All right, hit escape, Shift ZZ. Now, so if I do cat test, name.txt, this is what I get. I'm gonna clear that. Name, a cat name, name.txt. All right, I only have 4 names, but remember names, but I got them 3 blank lines. Cat, names, x.txt. This one got, I think, at least 10. So if I do a cat name, all right, I'm gonna take the one with 10 and put in the one with 4. So I'm a cat if I could type name x.txt, and I'm gonna use the double stream. All right. So I'm streaming it. It's almost like we do the CN in C++, and then I want to put it in name.txt and hit enter. All right. So now when I do cat name.txt, see what I have? I've just what? Concatenated or added to the name.txt file. All right. So everybody see that. But I'm gonna have to go back in my notes. I don't know why I did this though, because this is a command and then this is you can't do that. I don't know why I did that. I don't know why. See, yeah, this is wrong. That's what I did. This is wrong. Yeah, that's wrong. Yeah, that's wrong. My information that's wrong too. Just cat whatever. Yeah, that's wrong. That's wrong. That's wrong. That's wrong. That's wrong. Yeah, this wrong, and that wrong. So that's all that happened. So that's concatenating and showing, displaying the data. Now there's a more button. If I have data that like say a file with 2,000 lines of code, and I do a cat, it's just gonna keep scrolling. I could do a more, and what more gonna do? It's gonna just show me the first part, and then I can continue and see the next part. So if we look at it, it's telling us the more command displays the content of the file on one screen at a time. All right. The more, all right, the n% message, and we'll see that appears at the bottom of the screen, where n% is the percentage of the file that has been displayed. Okay. When the entire file has been displayed, the shell prompt reappears. Okay. When the more or the n% prompt appears at the bottom of the screen, you can use the keys described in the table on the following page to scroll through the file. If you hit spacebar, it just moves to the next page. You hit the return key, it's gonna scroll one line at a time. If you hit the lowercase b, it'll back up one space. If you hit the H key, it'll display help so you can see what you can do to do whatever. Now, you could do a slash string or slash, and then whatever the string is to search for a pattern. All right, so string here would be whatever string, like if you're looking for the word array, slash array, and then it'll look for that pattern. Capital N looks for the next occurrence, and Q quits and return to the shell. So if we go back here, and what I can do is I'll minimize this, and I'll make it like this and like this, because I think it'll do it in reference to this window. All right. So now, if I do a clear, and then I'll do a more, and then I'll do the file that I given you, which is what it was, name.cpp, name.cpp. See what happened at the bottom? It gave me more. So what? 34%. All right. But when if I hit enter, all right, one at a time, right? Hit the space bar, all right, it shows a page at a time, and then it finished. So see, those little options there allow you to manipulate how much you want to see of that file. All right. And this last one, this grep command, and I'll kind of briefly go over it, but it allows you, just like when we do the cat, it displays the document. The grep command allows you to list files that have lines in a file that has the content you're looking for. But then there's some options. You can slash -w, search for a word. -c counts the lines for matched words. So how many lines you found it on. /n gives you the line number, and -w inverts the match. So if I'm looking for every line that has array on it, all right, I'll do a -w, but I could do the -w and add add a V to it, and it's going to invert it to find all of the lines that don't have array on it. You understand? So that's basically what it is. So in here, if I do a grep, all right, I'm gonna clear the screen. So I know I have that file. Let me do a cat name.cpp. So that's the file. So say we got what? The word array. All right, we got the word array in here. So I'll do a grep, all right? And then I can do what it is, array, all right? And I didn't put no parameters in front, and I'll give it the name.cpp. Look what happened. It found it in this content, in this line, and this line. But now, if I had a large program and I didn't know exactly where it was, now I could do what? I could do a /-n. And now when I hit enter, oh, on line 17, this is where it is. Line 20, this is where it is. And line 26, this is where it is. So you can pinpoint where it is. Now, I'll show you something else I didn't show you. If I do VI names, all right, name.cpp. Now, it's open, but you really don't know what line 20 is or whatever. You could do a colon, and I think it's set number. And all of a sudden, now it's not in your code, but it's just showing you the number. Line 20, look, array. So you can look at the numbers when you're in the VI editor. You can put type colon and do set number, and it'll show you the line numbers of every line in your code or if it's a document or whatever. All right. So that's some of the commands and stuff. I gave you that assignment. It's not hard, but at least you're working through understanding how that Linux operating system works and some of the little things that it does from the command line prompt. So anybody have any questions? Any questions, issues, whatever? Anybody? Now what I'm gonna do, next class period, I'm gonna announce a test, all right? So read over your notes. Test gonna come from the notes. Study your questions. I'll do some true and false. May do some matching. May do some multiple choice. Or we'll do some multiple choice. So like I say, study, review the chapters or the material that we went over and whatnot. All right?
Sir, appreciate it.
All right. So no questions? I'll see y'all on next class period.
All right.
Questions? No questions. All right. So see y'all. Huh?
No, I was saying not for me.
All right. All right. See y'all on next class period.
All right.
All right. Miss Wisham. Miss Wisham. Miss Wisham. Miss Wisham logged in, Michelle. Miss Wisham. Miss Wisham.
Can you hear me?
Yeah, I can hear you. Hey.
Sorry, I have headphones in because I have my little siblings here and the microphone's not working.
All right. Hey, on that assignment, I'm gonna open that up so you can submit that. You didn't email it to me, huh?
I sent it through Canvas.
Oh, you
Like the
did?
pictures. Yeah.
So you was able to do the JPEG?
No, I sent it what format I could. I'm gonna change it to JPEG if I can.
Well, what I'm gonna do, I'm gonna go in and change. Well, for this assignment, I'm gonna change the settings to JPEG or PNG, so it won't be any issues.
Awesome. When is this assignment due?
This one is due by next week. You'll see it when you open it up and go to the module.
All righty.
Yeah. All right, then y'all have a good one.
You as well.
All right. Bye-bye.
Bye.